Hey guys, welcome back. In this video, I'm going to talk to you about this keyword independent. Two events A and B are independent if the probability of the second event happening doesn't change once the first event takes place. So for example, if I take two cards from a deck of cards, one after the other, and after I take out the first card, I never put it back, well, the probability of choosing your next card then changes. So this would not be independent, this would be dependent because the second card's probability changed because of the first card. So let's take a look at something or two events that are independent. Flipping a coin and rolling a die are independent. That's because if I say roll a die, it's not going to change. The probability of what you're looking for does not change because you flipped the coin. The coin had no effect on the die. Also, getting a state grant and a federal grant are independent events if the probability of getting a federal grant doesn't change because you got the state grant. So the probabilities have to stay the same as they would originally. If that's the case, then they're independent. So, there is a formula for independent, and we know this symbol here represents the word and. Two events A and B are independent. If we know that they are independent, then their intersection, this and, is going to equal to the product of the two events. So if I went back and I used this example here and I said, what's the probability of rolling a 1 on a die and getting tails when flipping a coin, then that's just going to be getting a 1 times the probability of tails. So the probability of getting a 1 when you roll a die is 1 out of 6, and the probability of getting tails is 1 out of 2. And so when we multiply numerator times numerator and then denominator times denominator, so you get 1/12. So that's a small probability. So this formula is actually really important when you are trying to determine if two events are independent or when you are told two events are independent. So let's take another look at another example. So in this case here, I said a person wants to buy a car. The probability that a person picks a blue car is 0.20. So I'm going to first start with my notations that we learned in the past videos. Blue car is going to be 0.20. And the probability that a person wants leather seats is going to be 0.15. So what is the probability that a person wants a blue car and leather seats? So what we're going to do in this case here is we're going to write just like this in notation, blue and seats. And because we know they're independent, you're going to do that's blue times seats. Well, that's going to be 0.20 times 0.15, and that should be 0.03. Just use your calculator and make sure that you're careful with the decimals. Let's try another example. The probability of coming to school late on any given day is 0.05. Not bad, guys. So that's going to look like this. Remember, notation and neatness is so important. Make sure your decimals are perfect. The probability of skipping gym class on any day is, so let's say skipping gym class is 0.07. What is the probability of coming to school late and skipping gym class? Well, first we have to make sure that they are independent. So I'm going to assume in this case that they are independent. Then that's just going to be the product of the two. Skipping gym class. So that's 0.05 times 0.07, and that's actually going to be really, really small. I'm going to use my calculator for this. I don't want to mess up with my decimals, and it's going to be 0.0035. Okay, you could tell there's going to be 4 places because the 2 and the 2. Okay, let's try one more. The probability of it raining outside on any given day in the month of April, so the probability of rain is 0.23. The probability of going outside to play on any given day in the month of April, so let's say go outside to play, is 0.05. Now, we obviously know there's going to be some sort of dependence. In other words, if we see that it's raining outside, we are not going to go outside. So we know they're not independent, but I'm going just to assume that they're independent just for this problem. What's the probability of it raining and going outside to play on any given day if they're independent? So rain and play is equal to rain times play. And so that's going to be 0.23 times 0.05. And I'm just going to punch that in, and I get 0.0115. You should always round to what they tell you to round, okay? Otherwise, leave it alone. So that's pretty much how we do independence, or figuring out the probability that of their intersection of two events. We've learned in the past videos that if I had a matrix or a table or a box, this is why I use the computer to draw the table because I can't draw them. Typically, these tables, when they have numbers in here, there's usually an overlap. So these events, let's say male, female, Democrats, Republicans, these typically are dependent. So in the next video, I'll show you how to determine if two events are independent. So that's really important, how to determine if two events are independent. So I hope this all makes sense. When two events are independent and you want their intersection, when two events are independent and you want their intersection is the product of the two events. And two events are independent if the probability of the second event happening does not change once the first event takes place. Okay, so come back for the next video.